So the problem here is design a sequence detector to detect the sequence 101 using a more finite state machine. Overlapping sequences are not allowed. So let me explain a little bit more about this. So let's say you have a clock. Let's say this is the first rising edge, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. Let's say your input is 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, and this is your output. So the concept is, as soon as you detect the sequence 101, you have to assert the output. And we are going to do this using a more FSM. In clock cycle 1, we get the input 0. So your output is 0 because you haven't detected the sequence yet. In clock cycle 2, you get the input 1. So that's a part of our sequence, but it's not our complete sequence. We are looking at 101. In cycle 3, you get a 0, but your output is still a 0 because the pattern has not been detected. In cycle 4, you have detected the pattern 101, but your output is still deasserted because in a more FSM, you're going to get the output one clock cycle after. So you're going to get the output as 1 in clock cycle 5, which means, so this is the first time that you have detected the sequence. In clock cycle 5, you get the input 1. In clock cycle 6, you get the input 0. You still haven't detected the sequence. In clock cycle 7, that's the sequence. So in clock cycle 8, you're going to assert the output. Now in clock cycle 8, you get the 0. So if you think about this, you have 1, 0. But if you read this, it says overlapping sequences are not allowed. So this is a overlapping sequence. So this is an overlapping sequence and it is not allowed. Your sequence has to be unique. So which is this one here. So this is unique and this is unique as well. But there is an overlap between sequence 2 and sequence 3. So your output is still going to be a 0. Now let's construct the FSM. So initially, when you hit the reset button, you go to the state S0 and your output is 0. So upon resetting the system, you are going to state S0. So here I'm going to write S0 can be reached if you are resetting the system. Now, when you try to design the FSM, you always go in a path so that you can detect the sequence. So we are looking at inputs 1, 0, and 1. So from S0, if you get a 1, you move to state S1 and your output is still a 0, which means you haven't detected your sequence yet. So S1 is a state that can be reached from the reset state by giving the input 1. Let's keep going. We are looking at 101. So when we get our input as 0, we move to state S2, but our output is still a 0. So S2 is a state which can be reached from the reset state by having the inputs 1 and 0. Next, we go for S3 state and we get a 1 here. So S2, you get a 1, you move to S3. So that is when your sequence is detected. Therefore, you are going to assert your output. So S3 is a state which can be reached from the reset state if your input bit pattern is 101. However, this FSM is not complete yet because if you notice from S0, you have the 1 transition. That is, if you get a 1 from S0, you go to S1. But if you are in the state S0 and you get a 0, where would you go? If you get a 0, it means you stay in S0 state because it's as if you are in the reset state, which means that you haven't started detecting the pattern yet. Similarly, S1 is a state which you were able to reach from the reset state by having 1 as your input. Now from S0, if you get a 0, you transition to S2 and your output is still a 0. So we have covered the 0 transition. Now, what if you get a 1 from S1? If you get a 1 from S1, it means that you are still in the same state because your sequence was 1 and a 1. So we are only looking for 101. So the best way to know where to go is you take S1, which is basically you reach there by having a 1, and from there you got a 1. Now you go and see if there is any state with 1 1. No. So you cancel out this one, and then you see if there is a state with 1, and that is S1. So you remain in S1. Now let's look at S2. So S2 was 1 0. Now you are completed with the 1 transition. You are still left with the 0 transition. Basically, your sequence is broken, which means you have to start from the beginning again. Again, to see where you have to go, look for a state which has the sequence 1 0 0. There is nothing in this list. Cancel the 1. Look for a state which has 0 0. Again, there is nothing in this list, so cancel that. Look for a state which has a 0. Basically, you have to go to the reset state. Remember, S0, if you are in the state S0 and you get a 0, you are in the reset state. So you go back to S0. Now let's do for S3. So S3 is a state which you got there by having the input sequence as 101. Now there are two possibilities. Next you can get a 0 or you can get a 1. Now remember here, overlapping sequences are not allowed. So in this case, since in S3 you have already detected the sequence, you can actually erase this. All you need to see is where you have to go for 0 and where you have to go for 1. If you get the input 0, there is a state S0 which matches to 0. So you go to S0. And if you get a 1, which means that you are starting to detect the next sequence, so you go to S1 because S1 can be reached by having a 1. This is how you design a more FSM where overlapping sequences are not allowed.